Scientists announced a breakthrough in determining life's origin on Earth and maybe even Mars. This is by Foundation for Applied Molecular Evolution on phys.org. Scientists at the Foundation for Applied Molecular Evolution announced today that ribonucleic acid, or RNA, an analog of DNA that was likely the first genetic material for life, spontaneously forms on basalt lava glass. It just spontaneously forms on things coming out of volcanoes. Such glass was abundant on Earth 4.35 billion years ago. Similar basalts of this antiquity survive on Mars today. Quote, communities studying the origins of life have diverged in recent years, end quote. This is what Stephen Benner remarked, co-author of the study appearing online in the journal Astrobiology. He said one community revisits classical questions with complex chemical schemes that require difficult chemistry performed by skilled chemists, Benner explained. Their beautiful craftwork appears in brand name journals such as Nature and Science. However, precisely because of the complexity of this chemistry, it cannot possibly account for how life actually originated on our Earth. In contrast, the Foundation study takes a simpler approach, led by Elisa Biondi. The study shows that long RNA molecules, 100 to 200 nucleotides in length, form when nucleoside triphosphates do nothing more than percolate through basaltic glass. Basaltic glass was everywhere on Earth at that time, remarked Stephen Moises, an Earth scientist who also participated in the study. He said for several 100 million years after the moon formed, frequent impacts coupled with abundant volcanism on the young planet formed molten basaltic lava, the source of the basalt glass. Impacts also evaporated the water to give dry land, providing aquifers where RNA could have formed. The same impacts also delivered nickel, which the team showed gives nucleoside triphosphates from nucleosides and activated phosphate, also found in lava glass. Borate, as in borax, also from the basalt, controls the formation of those triphosphates. The same impactors that form the glass also transiently reduce the atmosphere with their metal iron nickel cores. RNA bases, whose sequences store genetic information, are formed in such atmospheres. The team had previously showed that nucleosides are formed by a simple reaction between ribose phosphate and RNA bases. The beauty of this model is its simplicity. It can be tested by high schoolers in chemistry class, said Jan Spesek, who was not involved in the study, but who develops instruments to detect alien genetic polymers on Mars. He said, mix the ingredients, wait for a few days, and detect the RNA, end quote. That's amazing. The same rocks resolve the other paradoxes in making RNA in a path that moves all the way from simple organic molecules to the first RNA. Banner said, for example, borate manages the formation of ribose, the R in the RNA. This path starts from simple carbohydrates that could not have formed in the atmosphere above primitive Earth. These were stabilized by volcanic sulfur dioxide and then rained to the surface to create reservoirs of organic materials. Thus, this work completes a path that creates RNA from small organic molecules that were almost certainly present on the early Earth. A single geological model moves from 1 to 2 carbon molecules to give RNA molecules long enough to support Darwinian evolution. Banner's cautions important questions remain. We still do not know how all of the RNA building blocks came to have the same general shape, a relationship known as homochirality. Likewise, the linkages between the nucleotides can be variable in material synthesized on basaltic glass. The import of this is not known. Mars is relevant to this announcement because the same minerals, glasses, and impacts were also present on Mars of that antiquity. However, Mars has not suffered continental drift and plate tectonics that buried most rocks from Earth older than 4 billion years. Thus, rocks from the relevant time remain on the surface of Mars. Recent missions to Mars have found all of the needed rocks, including borate. If life emerged on Earth via this simple path, then it also likely emerged on Mars, said Banner. This makes it even more important to seek life on Mars as soon as we can. And this is on phys.org by Foundation for Applied Molecular Evolution. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.